So I see a question here in the chat from Aniket to explain the file name business once again. So Aniket, this is what you're talking about, this here, this file name. Okay. So what happens is that shared preferences objects, you can create them based on a file name you supply. You can call it anything here, any string. So let's imagine internally what it does is that when you save something, when you call this portion of the code here, which says put string and commit, you've created a key value pair. And this needs to be saved somewhere on the storage of the device, on the, not the RAM, but the persistent storage, the hard disk, if you want to call it that. So that needs to be saved in some file format. Let's say it saves this at .txt. So what it will do is it will use this file name to save it. So you can create, for example, you can have, and you can segregate information like this. You can say that, okay, everything related to activities that are about, let's say your app is a game which has many aspects, many levels. So you create a file name to save information about that level. Each level has its own file. You can do that. All you have to do is be consistent in saving and retrieving information. The other option was to just use get preferences instead of get shared preferences. And what that does is that each activity by default gets a preferences file. All your information will get saved into that. You don't need to supply the file name. So that's what it is. Does it help? Okay, good. So now what we will do is we will do the part that we said we are going to do after the break. So here is where in our first fragment we have two edit text, two fields of type edit text. And the way you know it is you go and select the field and it shows you its type here at the top right, that it is an edit text. So this is the Java class. If you click on the text view, it shows you as text view. If you click on the button, it shows you. This is the equivalent Java class here. So for us, we have these two edit text objects. And what we will do is we will create variables to hold them. So that's what we'll do. We'll just say edit text and we'll give them the same name as the IDs we gave. So this will allow us to have a reference to those two fields so that when we want to retrieve, as you will see, where we retrieve the information, we can just basically we have access to them without having to do another find at that point. So to get rid of this error, you just say import class and it's going to add it to your imports. Okay, so on in the fragment, you do this here in on view created, you add this here. You say name field equal to, see, just like on the very next line, we are using find view by ID and providing an ID. That's the exact same thing we have to do. You have to say view dot find view by ID and supply the ID we gave it. And for us, the ID is name field. Okay, and the same thing, phone field equal to view dot find view by ID phone field. Okay, so this is what it is, name field, phone field. Now what we want is, we know we have a reference to that. The functionality we are missing is when we press this next, we want the values that are displayed in these, what the user has entered, to be saved. So where do we add this? So right now the next button goes to the next screen. So we want it to keep on doing that. And in addition to that, we want it to save the value. Where would we look for that functionality? What happens? What is called when we click on this? It's actually right here. You see this, it says here, find view by ID button first. This was the first button. We didn't change its ID, it's what it gave us. Set on click listener. So this is what happens when a click happens, and right now it navigates. So what we want is before it navigates, save the info, right? And what is the information? What is the name? It is name field dot get text. So this has an error. What is the problem here? Is required type string provided editable. It's editable text. It's because it's editable. What it is getting you back is in what is called as an editable text. All we need to do is convert it to a string. That's all it requires. Same thing with the phone number. We'll say phone field dot get text dot to string. Okay, so now we have whatever was entered by the user, we have got it here. And saving it is now actually pretty trivial. So we have retrieved this. I'm going to go back to here in our top, go to main activity. Main activity, we have this static object, storage object. We can use that and call the save method. So we'll say main activity dot storage object dot save data, right? Key and value. Where did we define the keys? The base storage. So we'll use these as our keys. And you can hard code the string right here, but then you have to be careful about when you're retrieving, you don't make any typos, etc. By using a static string, you take care of all of that. If you make a typo, the compiler will throw an error. So we'll use this base storage dot name and the name. It should get saved at this point. Same thing to save the phone number. There it is. So that's how we can save it. So all we needed was collect references to these, and then from those we retrieve the text and save it. So you're seeing that here, nowhere we are saying save it using shared preferences. That is what abstraction is giving us. Later on, when we implement another method, we don't have to change these lines. Nothing changes here. Okay. All right. Everybody up to this point? Okay, so we have to do now the same thing in the second fragment, but reverse. We have to retrieve the information. So go to your second fragment class, and this time we will store references to the the display for the, oh, I have to get name disk and phone disk, right? So name. So name and phone number are the two things we are going to, set. So over here now we do the same thing as before. We retrieve the view dot find view by ID, and what is the ID? Our ID is name disk. So we basically retrieve references. We ask this find view by ID method to give us the two text fields. And make sure you're retrieving the display, not the field disk. And right here we can also retrieve the values. Just like we saved using the storage object, we'll retrieve. What is the name? Name is based on our key for the name. This will give us a string, and basically again use the storage object, retrieve data, and using the phone number key. Okay, so we've got the name and the phone number. Now we want to set it to the name disk and the phone disk. So you just say name disk dot set text name, and same thing for the phone disk. So here again, the class, the second fragment is completely agnostic to how you are saving the information. It's only interest or retrieving the information. It's only interested in the behavior of retrieving the information. How the class does it, it does not care. So what we did is we added these two lines and these lines here. And now when we run it, we should actually see the information being saved and retrieved. Okay. So this is, it looks the same as before. Okay, here right now, see the information, there is nothing saved in the database. So whatever it is returning, it's not returning anything actually. So it is basically showing the empty strings. I'm going to type my name here and a phone number. And now what we want is when we say next, this information should go saved in the preferences. And then when the next screen loads, it reads the same information and displays it. Let's see if that happens. So it does, right? And when we go to the previous, because we have not reinitialized it to what was already there, it gives us the empty slate again. So now, this time we can enter some other name and some other phone number. So now what we are seeing is that it's getting stored with the same keys. So it's going to overwrite and show us the new values. So far, what you have seen is, the lot of things we have covered before. These are not new to you. For example, how to set the text in a text field. All of this we have seen before. What additional things we have seen is how to save the information, retrieve it using shared preferences. That is more like a review. And also the whole abstraction thing that we've been talking about. So we'll implement one more method of doing this. But before we move on, I just want to make sure that all of you are up to this point. Anybody still working on this?
Yogesh, can you go over once more with this all these things
Which
after
one?
the break? After the break, what you did?
After the break? Okay.
Yeah, everything. Just
Okay.
overview.
Okay. So after the break, so when we took the break, we had up to this point, we had created a storage object. This is going to provide the storage functionality to our app. We created a static object. So now we have to use it. So to use it in the first fragment, what our first fragment shows is two blank fields. So when we press next, we want to be able to retrieve the value, what was in the name and what was in the phone number, and save it. So to be able to retrieve these values, we need to have references to these two. So those references we started creating. First, we declared two properties here, two class variables, one for the name, one for the phone number. And on view created is when they become available to us. So we retrieve them. We use the find view by ID, and this is the ID we gave them. So it is a coincidence that this and this is the same. We can use a different variable name here, and we can apply that here. So we retrieve the reference to the name and the phone number field in our view. And then when in this on click listener is what happens when that button is clicked. In this, the first thing we do is we say, okay, what is in this field? What is the value? So we use the get text or toString. And what is the phone number, that value? And then that storage object that we have in our main activity, we call it save data method and save the name with the name key. This is the key we defined in our base storage, and save the phone number with the phone number key. These are strings. You could very well just type a string here and it will use that as a key. But using a Java variable, make sure that when you are retrieving it, if you make a typo, it will crash the program. It will not even compile, forget about crashing. Those things can be hard to debug. So it's a good idea to define all your keys as static Java variables. So this saved it. And now to retrieve it, we do the reverse in the second fragment. We use the retrieve data to retrieve these values. To be able to set them to the display fields, the display, the view here that is displaying them, I have to enter some data. Okay, so to display it here, you need a reference to these, which is what we did here. First, we declared the text views as local variables, class variables, and we retrieve them using find view by ID, and then call the set text. That is what causes those things to show up there. So we are not passing any information between the views. We are saving from one view, we save, from the other view, we read and display. So if you are using any kind of functionality in your app where you have to save information and they are key value pairs, you can use this method. So I'm sorry, was it Ravi who asked me to repeat this?
Yeah, I got it.
You got it? Okay.
Yeah, because I was just cooking my breakfast now, so I just skipped the first 5 minutes when you started on the break. So I
Okay.
got it all. Yeah,
Okay. Good.
thank you.
So hope you're caught up. Anybody else have any questions? Okay, let's go back to our slides. So this is what we have done so far. We created the shared preferences class, we implemented the methods, and now we are using it. So the next thing we want to do is we want to do all of this, but this time we'll store it into files. We'll store the information to a file. So what we need to now do is know how to save a file and how to read a file. So just like we implemented a using shared preferences class, now we will implement a using files class, which will do the same thing. It will extend the base storage and it will implement the missing functions. And I'm going to give you this link here because we will, to speed up some parts of the process, we will just pick up the code that they suggest. So let's start. You don't need that yet. Let's start here first by creating a new Java class in our storage package. So right click on the storage package, new Java class. And this one we will call using files. So storage using files. Give us the same empty template as always, and this time we will extend base storage. And base storage is an abstract class, so as soon as you extend it, the studio, your development environment will complain that unless you implement some methods, this class should be declared abstract. So we'll just say implement methods and choose both the methods. So these are the two methods we need to implement. So now we will save the data to a file. And read from file, right? This is what we'll do. So extend base storage to create this and add the missing methods. And let's see now, let's look at how information is saved to a file and read from a file. This is the link I gave you. Accessing app specific files, internal storage directories. So these internal storage locations, no other app can access, like I said before, and this is what we will do. We will not store in an external storage. So the way we do it is basically you can use the file API, but then you have to know what to do with this file object, how to use it to save information and retrieve information. It is easier to save a file using a stream. Stream is like a stream of text. As you basically, you may be, let's say, reading some information from the internet and saving it locally, or you may already have a string that becomes your stream. This is the example here. They have a file name, they have a string that they want to save. And here again, you will see that you need a context, because without a context, you cannot open a file for output. So we will have to do the same thing, have a constructor that receives the context. And then you open file for output, give it the file name and the context mode. And this gives you a file output stream when you do that. And then you just write to this stream. This is what we are going to do. And then to read the file, it's a little bit more complicated. Java is like that, but it's good to know. So let's do this. This part is simple. We'll just write the code ourselves, the saving part. So what we will do is, this is a demo. In a real world, you will not do this. We'll use this key as the file name and save the value to it. In the real world, in your application, you may not be using one file for one key. If you have key value pairs, use shared preferences. This is the method you would use, for example, if you are saving an image that somehow you have downloaded, or if the user has created a long piece of text that you want to save as a file. Stuff like that you will use it for. Saving files is pretty common, so it's good to know. So we are going to do this. So what we need is, first of all, we need a constructor. So create one public using files, which takes a context as before. And this context, just press Alt Enter to import it. And we'll declare a class variable for the context. So it will become available to us in the save and retrieve methods. Now inside the constructor, all we do is assign the class variable to the argument we receive. Okay. And now what we'll do is file output stream. In our save data, we can say file output stream equal to context. Oh, I have to give it a name. I'm just going to use the initials FOS dot. You may not see this method right at the top, but this is the one we are going to use. So start typing open file output. This will return a file output stream. And it takes two arguments, a file name and a mode, same as before. So we'll say key, and the mode is going to be mode private. It's going to be saved in a private location. Right away, this should complain unhandled exception. So we could have typed all that try catch, but we can use Android Studio to do that for us. Press Alt Enter or use the other option that I just did and say surround with try catch. So now it knows that if this file cannot be created, then there is going to be an error and it's going to print it out. But in case it is going to be created, we are going to write to it. Value dot hang on, I think we need to convert it to a byte array. Yeah, 2-byte array is what we have to do. Why is this not a method? That's very strange. In their code, it is a method. In our code, it is not. I think we just have to say get bytes instead. Unhandled IO exception. So what we can do is we have two choices. We can add another catch clause, which will catch that exception separately, or we can change this file not found exception to an IO exception, because file not found exception is a type of IO exception. IO exception is a parent class. So regardless of whether the error is caused by the file not being found or not being able to write, file is there, but maybe there is no space on the disk. Any kind of that kind of an error, it is going to complain. And this is what it will do. And this stream, I think we need to close it after we write to it. So now we have written the information. We need to retrieve it. So this is how you work with a file. You get a file output stream. To write a file, you get a file output stream and you write to it whatever you're writing. Could be, here we are writing a simple string. You could be writing, let's say if your app allows the user to record something, an audio file, you could be writing that. Could be right if you're taking a picture and the user is making some changes, you may be saving it in your internal app storage. You don't want that picture to go be visible to other apps. So all of that you will do like this. Now, when you write information, stands to reason that at some point you will want to read it. So this is how you read information. Just like the output stream, we create a file input stream. And reading from an input stream is not a simple matter, because what happens is they have a class called input stream reader, which can read from it. And depending upon what the character set is, it reads properly. You have to specify that. Eh, On top of that, what happens is when you are reading a stream, you don't know in advance how big the data that it is going to read at what speed. Like for example, if you're reading from the internet, things may be coming slowly. You could have an input stream reader that reads from an internet stream, but you don't know how fast it is going to come. So what you do is you wrap it into a buffered reader. That's what this is doing. It's creating a buffered reader which reads from this input stream. And what it does is it reads line by line and keeps adding to the your string builder. This is where your final output is going to be. So this, the whole thing, I want you to copy it. We're not going to try to type it. We'll just change the file name to our key and return these contents. So open this page and copy it. And over here, we can paste it. We'll be able to fix all this. So first of all, you just keep pressing Alt Enter to import these missing classes into your okay. And what is its problem? Okay, try with resources requires API level 19, current min is 15. We'll fix that in a moment. This is probably the same, yeah. So this is API level 19 and above, and I'm pretty sure they talk about it here. Somewhere they should say that this is only available in API 19 and more, and that there may be other methods which are more universal. So they don't say it here, but I will leave that to you. If you run into that and you must support below 19, you may have to use just slightly different classes. So we have two problems here, the file name. So you see the file name we used was the key. We'll provide it the key as the file name. Okay. So let's fix things one by one. This was also complaining that this can throw an exception. Why aren't you using a try catch? So thanks to Google, copy paste did not work as I thought it would. Let's first fix the minimum to 19, API 19. Where do we do that? Where would you go to make this change? App Gradle, exactly. You go to your app Gradle and you will find all the settings that are related to the versions and all. So here it says min SDK 15. That 15 was picked up from here. It wasn't magically done. Now we'll change it to 19 and say sync now. Must say sync now, otherwise the other place will continue to show errors. Okay, so those two are gone. This is still here. That, oh, this can throw an error. This is actually a simple fix. Just this try block, right? What we'll do is we'll delete this from here and delete its opening bracket. And put it over here. So we are saying that try this whole thing. And anywhere there is an exception, just catch it right here. And finally, you familiar with this word finally? What it does? So after it's done with trying and catching whatever it is doing, it is going to execute this. So anything that you must do, regardless of whether try is successful or not, you will do it in finally. And because this string builder is declared inside the try block, it's complaining. We need to take it out and put it outside. In fact, we can actually, we don't even need this. We are appending to the string builder, right? So over here, we can just say string builder dot toString, return this. This is how you're going to read files. Understand this. If you're saving something in your app and you want to read it from the internal storage, these are the steps. You create a file input stream, and then you create an input stream reader. But because the input stream reader itself, you cannot directly read, even if you can, it may be a lot more cumbersome. Using a buffered reader allows you to read line by line, for example, or you can specify a buffer size that read 1,000 bytes at a time and keep reading until there are no more bytes. Just like here, it is reading one line at a time, and then when there are no more lines, it goes out. While it has lines available, it keeps appending to the string buffer. Okay, so these are our two methods: save data and retrieve data. Now, what do we do now? We want to use this class instead of this, using files instead of using preferences, shared preferences. It's a very simple change. You go to your main activity, and where you are instantiating these shared preferences, you can just change it to using files. That's it. That's all the change you need. You don't need to do anything. You don't need to go and change the code in the first fragment. Oh, this time you save to a file. None of that business. This is why we use abstraction. Okay, let's run it now and see what we get. So we are using files. As long as we see our information getting stored and retrieved, we know that it's being saved to a file and being read from a file. So let's see what happens this time. Okay, so this is what we want to see. See, this is now coming from a file. You're curious, you can put some log output, output it to the log from those functions. This is where it's doing all the magic of saving to a file and reading from the file. So everybody getting this up to this point? Okay, good. So these are, see, using abstraction, we created two methods of saving information. And in the beginning, we said that there are many more methods. So let's see what else is there. So this is what we just did, save and retrieve from to and from a file. SQLite. SQLite is basically like any SQL database. So when you're creating a database, you define a schema, you define what your columns are going to be like, what each column's type is, etc. Then based on that schema, you create a table and then you run queries. You can save information, you can retrieve, you can update. There are different queries for it. And these will look like SQL queries. And this is what I'm going to give you this link. Okay, and let's look at what is in this page. Save data using SQLite, and you will see that there is a big warning here. I will come back to this. But the process is like this. You define your schema, you define what your table's name is going to be and what your column names are, all the column names. So as many table, let's say, that same Kijiji ad type thing, you want to define a table for your ads, define a table called ads. And all the things an ad must have, you define as a column: title, subtitle, description, price, who posted it, when they posted it, all those things you just put here. And then you create a query to create the table. So this is your SQL query: create table, the name of the table, the name you gave here, and you define what each column is. So there is an ID field, which is an integer primary key. Then there is a title field, defining it here, which is a text, etc., etc. So this is going to create your table. And then to work with the table, you need a helper class. So what it does is SQLite has an open helper which allows you to open the database for reading, etc., and do things while it's, what to do when it is creating, etc. So this helper will do things that you ask it to do. So you will see here a method called onUpgrade. This is why SQL databases can be a little tricky to work with in your apps. You go from one app version to the other. In your first version of the app, you have, let's say, 4 columns: name, phone number, email address, and physical address, right? You have 4 columns, and the user is using that as an address book. They're creating that. And then in the second version of the app, you decide, oh no, I don't like this name. I want it to split it into a first name and a last name. Now, what do? Your user has already got, when they upgrade from first version to the second, they've got maybe 100 entries with just the name. What to do with that is what you specify here. And that is actually a real headache if you think about it. What do? Here they are saying delete all the entries. You don't delete, your users are going to be upset if that's critical information. So here is where you will define: on upgrade from this version to this version, you do this. So you may have this on upgrade method, many clauses here that if you are upgrading from version 1 to version 2, this is what you do. If you go from 1 to 3, this is what you do. If you go from 2 to 3, this is what you do. So put a lot of thought if you're using SQL databases, SQLite in your app, put a lot of thought into the schema beforehand, make it more general than you think you're going to need. Otherwise, you will be spending a lot of time testing and coding what to do on an upgrade. Yeah, similarly, there is on downgrade also. So you can imagine all the fun. So this is what this open helper does. Actually, it needs a lot of help itself. So I don't know why it's called helper, but that's the way it is. And putting information into a database, you get a handle of the database, get writable database from the helper. And putting values is actually fairly simple. You create a values object, which is basically like a hash table, like a key value pairs itself. And you add all the values you want to put into the database into this. And then you run an insert query. This is your SQL query, db.insert. Reading is just the opposite. It is going to read and give you actually, you create a query. So what are you doing here? Get column, cursor. Okay. So what it does is you run a query, right? Where you say this is the table and the array of columns to return. And this is what your where clause is, selection. So if you see the selection here, you're saying that where your title is. Have you seen queries in other languages that when you build, you use a placeholder, that the query is actually, instead of using an actual value here, you use a placeholder and then you supply the value in another array. Have you seen this in maybe in other languages? So this is what it is. Yeah, you will see this in many, the PHP probably has this. I know Perl has this. So this also prevents what is called SQL malicious injection. You've heard of this term, right? Code injection, where a malicious party can try to, play around with your code. So what the way they do it is, if you had, imagine that you are asking the user to type a username and you say, okay, I will check my database if that a user with that name is present, and you build a query, and in your query you write something like where username equal to whatever the user has typed. So let me just open a piece of code here. I'm going to just here type. So you say, select from my table, select star, where username equal to, and you actually in your query you put what the user typed here, right? What this does is, if there is a malicious user and they want to see if your code as a whole, what they will say, instead of filling XYZ in your form on your website, they will put XYZ and then put a closing thing, put a semicolon, and then run delete star from my table. This is what they enter, right? So I'm going to paste this in your code here and you see what happened. This is not one query, this is two queries all of a sudden. It is going to, actually there is a semicolon here. It is going to run the first query, doesn't care about the output, then run the second query. It will delete all the rows from your table. This is what is SQL injection. And you want to avoid this. And the way you avoid it is by, okay, let me go back to this. What you do is, the way you avoid it is, when you are building your query, instead of this, you just say question mark. And then when you are running the query, that's when you supply that argument. This becomes your argument. So instead of inserting that there, you say query dot run, whatever the thing is. And as many question marks you have, that many values you will provide here. This is safe. This checks. This will escape everything. You don't need to worry about it. So it will actually look for a user by this name. It is not going to split this into 2 or 3 queries and do whatever the malicious user intended. So these are compiled queries. They get compiled on runtime instead of and the values, whatever placeholders, they get replaced. This is how you should actually always be. If you're building a website and getting user input to use in queries, never add it to a query. You're creating a big security hole. What you do is you use these question marks. So your selection criteria has one question mark. So your selection arguments has one value. That's what it's doing, your selection criteria and the whatever to replace the question marks with. So you build a query, you run it, you get a cursor. And this cursor, basically, you may get more than one value, right? Let's say 10 rows matched. This cursor will point at the first row. And then you keep moving to the next and keep retrieving and doing whatever you want to do with those results. Sometimes you may expect only one value. And in that case, let's say you are running a query on the primary key, you declared a primary key, that will return only one value. So at that time, you know that even though it's a cursor, it has only one value. So we're not going to do this as an example in class. I just wanted to talk to you about it and point you to the resources. So it can be hard to manage schema between, changes to the schema between app versions. We already saw that. And because of how you saw, how much code goes into putting data and reading data, and then even if you get a cursor, what it gives you is, you know, a bunch of from the current value, you have to retrieve one by one the column indexes and put into the equivalent Java. It's a lot of work. It's very useful because the SQL, being SQL, it provides you a lot of power to run queries, and if you need those features, this is a good choice. Google also suggests in their documentation right at the top, they caution about some of these things. They're fairly low level and require a great deal of time and effort to use. So they recommend using what they call room persistence library. So you can look at that if you're curious. And I pasted the link to this page, so you can just go from there if you want to do that. So that's about SQLite. Firebase databases, we sort of talked about it a bit when we were doing I think it was the push notifications. So Firebase gives us two options, Firestore and real-time database. I'm going to give you the link to both of them. And we will look at it briefly. Okay. So these also we will not do in class because this is an entire lecture in itself. What you can do though is, what we can do quickly is getting started with Cloud Firestore. The steps are very similar to what we did for the push notification. You create a project in your Firebase console, and then you create a database there. You, in your Gradle, you specify the framework, Firestore framework. And then in your activity, you create an instance of the Firestore. And basically on that instance, you can you can create a map. This is going to create your JSON object that it saves. First, last, and born are the three fields, and these are the values: Ada, Lovelace, and 1885. So you create, this is your JSON object in Java. It's not in JSON notation. It will get saved in JSON notation. And within your database that you retrieved here, you just say create a collection. If it's not there, it will create it. So this is like, if you're using MySQL, this would be your table name. And then you add a user. And on success, you do this. On failure, you do this. These are the two listeners that this add method provides you. So this is how you will add information to the Firestore. And retrieving is the reverse. From that table name, you say get, and it will get, actually, it will get all the values. You can specify more, you can run queries. Firestore has that power to say, okay, get me the user whose first name is Ada or who was born in 1815. All of those things it will do for you. So that's Firestore, and real-time database is right here. It's very similar, the usage, etc. So this Android is what we are looking for. Get started. You'll see that very similar, the same thing, same steps. You create a real-time database in your Firebase console. You import the framework. You instantiate the database, and then set value, retrieve value, all of that business. Okay. Any questions about the storage part? We have finished what we wanted to talk about: data persistence, abstraction, and we ended up talking a little bit about security. Any questions, guys? A lot of material we went through today. If you have questions, please speak up.